Hey guys, this is question MM051 of the Maths Methods Sharpened Study Guide. We've got a function, h, from negative infinity to b, where h of x equals 1 over x squared plus 2, all squared. Now this is a very unusual graph. You may not have seen this before. It's quite uncommon. So first step is to sketch this on your calculator and see what it looks like. You'll see that it looks like this, with a turning point at x equals 0. It doesn't matter what the y value is at this point. So what we're trying to find out is the restricted domain for which this graph will have an inverse function. And the question is, why would it not have an inverse function? In order to have an inverse function, a function's domain must be restricted to allow the inverse function to be a one-to-one function. What I mean by that is when you create an inverse, if the inverse is a one-to-many or many-to-one function, that is not classified as a function and will not work. So we need to restrict the domain to be only one-to-one in this case, because this function currently is a many-to-one, but we want the domain to restrict it to be a one-to-one function. That is one x value for every one y value. So basically we don't want it to be a many-to-one. So let's just run through the list and see which ones apply to this. So we've got our domain. So it starts at negative infinity, which is all good, and it goes up to b. So if b is greater than negative 2, let's call negative 2 here. Let's call that positive 2. If negative 2 is here and b is greater than negative 2, that includes all this part here, which doesn't actually work because that creates a many-to-one function. So and what we're looking for is a one-to-one function, so that doesn't actually work. So with b, if b is less than or equal to 0, which is this point here, if it's less than or equal to 0, it's everything included that way, which means that from negative infinity to 0, every possible value in here does produce a one-to-one function. So that would actually be our answer, b. Let's run through the others and see why they don't work. C, b is less than 2. So if b was less than 2, that would include everything from 2 to negative infinity, including this part here, which would create a many-to-one function, which is what we don't want. D, if b was greater than or equal to 0, it would include everything along this side of the graph, which again produces a many-to-one function, which we don't want. And E is exactly the same, greater than or equal to 1, which would be somewhere here, and it would include everything along here, which would create a many-to-one function from negative infinity to positive infinity. So our answer is B. B is less than or equal to 0, because this section here would create a one-to-one function, allowing this function to have an inverse.